Good afternoon or evening. Welcome to lesson 2.5. Okay. Now, before we start with the exploration, we're going to start with a little bit of theorems. So please go to page 56. And today's lesson is on proving statements about segments and angles. Okay, so we are on page 56. Now, today is our introductory to proofs. Okay, so 2.5 is going to ease us into are those dreaded proofs that not a lot of you guys are going to like, but they're very, very important. Now, why do we do proofs? Okay, one of the reasons why we do proofs is because that is how mathematics pretty much got invented. When a mathematician came up with a main idea, he or she shared their idea to the mathematical community. In order for that to be an accepted idea, it had to go through a rigorous process of being proven. It wasn't like, hey, here's an idea, let's all use it now because I'm really smart and let's all agree that what I just invented, it's gonna work. Okay, it doesn't work that way. So pretty much, if it's kind of like how we're trying to develop a vaccine right now. You developed a vaccine and everybody's not like, oh, you have a vaccine, let's all use it. Well, people don't really do that. They actually go through a rigorous process of proving that vaccine is effective. Mathematics is the same way. You got to prove, what it is that you just came up with. So in order to do that, we need a couple of facts. So here are two theorems that we need to know. Now, I don't recommend you learning the theorems by the number, like don't remember theorem 2.1. Try to memorize them by the names, like for example, the properties of segment congruence. Okay, so here you can see in the first one that segment congruence is reflexive, symmetric, and transitive. So what does that mean? Reflexive. For any segment AB is congruent to AB. So in other words, a segment is congruent to itself. Symmetric property. If you have two distinct segments, if AB is congruent to CD, then CD is congruent to AB. Transitive property. If segment AB is congruent to segment CD and segment CD is congruent to segment EF, then AB is congruent to segment EF. Now, this is a theorem. So what's the difference between a theorem and a postulate? Okay, postulates, they're made up of definitions and they're just accepted facts. Theorems, you can actually prove them. So all of these right here can be proven, and we're actually going to be probably proving one or two of these. Then you have the properties of angle congruence. So angle congruence is both reflexive, symmetric, and transitive. So the reflexive property, any angle is congruent to itself. So angle A is congruent to angle A. Now, let me tell you guys something. We are going to be using the reflexive property quite a lot. So try to memorize the reflexive property. The next one is the symmetric property. If angle A is congruent to angle B, then angle B is congruent to angle A. Transitive property. If angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. Now, just so you know, problem 4 is going to go down here. Okay, problem 4 is going to go down here. Now, the numbers don't really go in order. This is on page 56. Problem 1 is going to go right there. Okay, so 1 and 4. 1 up there. And on the next page, I know it's kind of small, but 3 goes up here and 4 goes down here. Now, before we begin our exploration, I want to talk a little bit about what is a two-column proof, because that is the main thing that we're going to be using. Okay? An example of a two-column proof, it has the main components. It has a given. This is what information is provided for you, kind of like for free. And then what it is that you are trying to prove. Now, if you have a given diagram, even better. Now, the two-column proof has two columns, obviously. It has the statement and it has the reasons. On the left-hand side, you're going to be writing down all the steps that take you through the whole proof. So it's the statements based on facts that you know or on conclusions from deductive reasoning. On this side, you're going to be writing the definitions, postulates, proven theorems that allow you to state that the corresponding statements are true. How many steps are there going to be? The number of statements, it will vary. You can have a proof as short as 3, or we have seen proofs as long as 14, and when I was in college, 2 pages back to back. Not lying about that one. Now, remember, you have to give the reason for every single statement, including the last one. And usually your first statement is always your given. Okay, so let's take a look at this proof that is already provided for us here. Okay, so proof of the symmetric property of angle congruence. That's the rule, the theorem that says that if angle A is congruent to angle 2, then angle 2 is congruent to angle 1. Okay, so that's what we're trying to prove here. Okay, now let me see if I can get this a little lighter. I feel like there's not enough light. Okay, a little bit better. All right, so what you have here is you have angle 1 and angle 2. Now it's given to me that angle 1 is congruent to angle 2. Okay, so the given is always going to be the very first step. The reason, because it's given. Your very last statement is, it should be what it is that you are trying to prove. Now, whatever happens in between, that's the magic of proving this. Now, angle 1 is congruent to angle 2. So by definition, their angle measurements are equal. So the measure of angle 1 equals the measure of angle 2. Definition of congruent angles. Okay, so when two angles are congruent, their angle measurements are equal. So now, when you set these into the measure of an angle, now we're talking about a real number. And we have properties for real numbers. So we can apply the symmetric property of equality and reverse the order of these two. So the measure of angle 2 is equal to the measure of angle 1. Why? By the symmetric property of equality. And that's the strategy that they're using here. The strategy is convert this into equality so that I can apply those rules like the symmetric property. And now that I have the measure of angle 2 equals to the measure of angle 1, we know that any two angles that have the same measure, they're going to be congruent. So therefore, angle 2 is congruent to angle 1. And you notice how this is going to be the very last statement. Okay, so let me color code these so that it can make a little bit more sense. Okay, your given is always going to be your first statement, and your last statement, it's going to be whatever it is that you are trying to prove. Okay, so this is a very short example of a proof. Now, I'm going to do some proofs where part of these are going to be given, or maybe they're going to give you all the statements but none of the reasons, or some of the statements and some of the reasons, but eventually we got to work our way up to us not being given anything except for what we are given and what we have to prove. And everything else is going to lie, on us. Okay, just remember 3 and 4 are going to go right there. So now we're going to proceed to the exploration. Okay, so please go back to page 54 in your journal. Okay, page 54 in your journal. Okay, so one of the things that you have to see is what it is that I am given. Okay, I am given that AC is equal to AB plus AB, and it's in reference to this diagram right here. So AC is equal to AB plus AB. And I'm trying to prove that AB and BC are congruent. Now look, they already gave me a bunch of stuff here. All I got to do is finish this off. So like we said, the first part is your given. Okay, that's going to go right there. Now the strategy that they're using here is the segment addition postulate. Okay, so the segment addition postulate goes like this. AB plus BC equals AC. Okay, so AB plus BC equals AC. Okay, that is the segment addition postulate. Now, let's take a look at our statements. You have AC equal to AB plus AB, and AB plus BC equal to AC. Okay? So here's the thing. I know this statement comes first, but if we read it like this, if AB plus BC equals AC, and AC equals AB plus AB, then because these two right here, they represent the same quantity, that makes these two statements equal. So you're going to have, excuse me, AB plus AB equal to AB plus BC. Okay, and this is going to be the transitive property of equality. Now, how did I do that? Keep in mind that this and this, they're the same thing. Okay, so therefore, this and this are going to equal. Okay, so this and this are going to equal each other, which is what happens in statement number 3. Now, if you look at this, you have AB plus AB, AB plus BC. You notice that you have an AB on both sides. So if you were to subtract those, now you have AB plus BC. Okay, and what we did was the subtraction property of equality. And therefore, now I have proven that AB is equal to BC. Okay, so this should be the very last statement. Okay. All right, let's look at exploration 2. Now, I don't like how they structured this exploration because, you know, I'm not going to go back from this page to the next page. So I'm just going to pretty much copy all of this onto, I'm going to copy all of this onto the very next page. Okay, so go to page 55. Excuse me. Sorry. Allergies. Okay, so now I'm just copying it down from the previous page. So it is given, okay, it is given that the measure of angle 1 equals the measure of angle 3. Okay, and what we are trying to prove is that the measure of angle EBA equals the measure of angle CBD. Okay, and the diagram that we had was this one. Okay, so you had 1, 2, and 3. You had this angle and this angle congruent. This vertex here was B. I'm literally just copying down the diagram from the previous page. C, E, D, and A. That way it's all on the same page. Okay, so like we said, our first thing that needs to go in here is what is given to me. Okay, so the measure of angle 1 equals the measure of angle 3. Okay, so now what we're going to do is they give me the second two steps. Okay, we know that angle EBA is made up of angle 2 and 3. So look, EBA is made up of angle 2 and angle 3. So EBA is equal to the measure of angle 2 plus measure of angle 3. That is the angle addition postulate. Now, take a look at this. The measure of angle 3 is going to be substituted for the measure of angle 1. Why can I do that? Because of statement number 1. And that's the substitution property of equality. Now, let's make a little parentheses there. Let's look at EBA. Okay, EBA. Actually, no, let's overstepped here. Okay, what we're going to do is we're going to flip the order of these two. Do you technically have to do it? No. But just so you can see a little better, let's just flip these two. So the measure of angle 1 plus the measure of angle 2. If I were me, I wouldn't have done it. But That's how they did it. So they flipped those two. So now let's just take a look at just the diagram. Okay? If you look at the diagram, angle 1 and angle 2 is made up of angle CBD. Okay? So angle 1 and 2, that's the measure of angle CBD. Okay, so now check this out. Isn't this the same thing as this? It sure is. Which means that by transitive property of equality, this and this are going to be equal. Okay, so we just proved that EBA is the same measurement as CBD. And hence our proof is finished. Now, they gave us half of the proof. The next proof we're going to do does not give me that. It just gives me this, and it gives me nothing. Okay, don't worry about number 3 here. Okay, so what we're going to do is we are going to create our 2-column proof right here on the side. Okay, so whoops. Okay, so let's read what they want us to do. You don't have to write statement and reason. I know you were doing that. Okay, B is the midpoint of AC. So B is the midpoint of AC. And C is the midpoint of BD. So I'm trying to show that AB and CD are equal. So it looks like it's a very hard concept, but honestly, it's not. You just got to use the definitions. Let me zoom in a little bit. Okay, so what does it mean for B to be the midpoint of AC? So let's just look at that. If B is the midpoint of AC, that means that 2 segments are being created right there. They're going to be congruent. So in this case, because B is the midpoint of AC, AB and BC are going to be congruent by definition. So we mark them congruent. And then we move on to the next step. C is the midpoint of BD. So I'm going to cover this. If C is the midpoint of BD, then BC is congruent to CD by definition. And we have to use the same hash mark. So what do we know about AB and CD? Well, they're going to be congruent. And if they're congruent, their measurements are going to be the same. So AB equals CD. So everything that I just did right now, that's called a plan. Okay, you have to develop a plan before you start any proof. And that's probably the hardest thing. Come up with a plan that's going to work. Okay, but we have a plan now. All right, so let's go ahead and start. All right, step 1. We got to list what's given. B is the midpoint of AC. That's given. In the same one, C is the midpoint of BD. I know it's kind of small. And both of these share the same reason. Given. Okay, so what does it mean for B to be the midpoint of AC? B being the midpoint of AC means that AB and BC are congruent. So AB is congruent to BC. Okay, that's from this. And C being the midpoint of BD, okay, we can say that BC is congruent to CD. Both of these will have the same reason, and it's called the definition of a midpoint. So if a point is a midpoint, it creates 2 congruent segments. Now, if you look at that, AB congruent to BC, BC congruent to CD, by the transitive property of congruence, AB is going to be congruent to CD. And this is the transitive property of congruence. So now that we know that the two segments are congruent, that means that their measurements are equal. So AB equals CD. And this is by the, hopefully I can fit it in here, definition of congruent angles. That's the symbol for angles. When I don't want to write angles, I mean not angles, I'm sorry, segments. There's no symbol for segments here. Okay, definition of congruent segments. Okay, we are ready to start our examples. Okay, the thing with chapter 2, guys, it's an annoying chapter, I'm not gonna lie. But you know, it is what it is. All right, so let's look at our first example, and it's gonna look a little familiar. Okay, remember that flashlight problem? Yes, we saw that in the previous lesson for example number 4. Okay, so let me recap what that problem was about. Okay, so you have a flashlight, and in this flashlight you have angle DBA and CBE. Okay, I know they're kind of hard to see, but these are the points that my printing did not help come out. Okay, so what we're going to do is we are going to convert the same problem that we did on example 4, and I actually have it right here. It's this one. Okay, that's the one we did. I don't know if you remember it. Okay, but we're going to convert this into a 2-column proof. Okay, all we're going to do is just literally put 2 columns in there. But let's go over it again, just in case you don't remember what was going on. All right, so we're going to make our 2 columns. Okay, our first step is going to be list what's given. The measure of angle 1 equals the measure of angle 3. And what we are trying to prove, we are trying to prove that DBA is the same as EBC, the measurement. So that means that we need to somehow figure out, you know, how they're going to be equal. So this first part is given. Now we did start off with angle DBA as the sum of angles 3 and 2. Okay, so in the second step, we have the measure of angle DBA equal to the measure of angle 3 plus the measure of angle 2. Look, DBA, that's the measure of angle 2 plus the measure of angle 3. And this is the angle addition postulate, abbreviating. Then what we did is we substituted the measure of angle 3 in this expression with a measure of angle 1. So the measure of angle DBA, we're replacing that one with the measure of angle 1. Okay, and what we did was a substitution. Okay, now let's take a look at what does the measure of angle 1 plus the measure of angle 2 is. Well, looking at the diagram, 1 and 2 is angle CBE. EBC is the same thing, CBE and EBC. I'm going to call it like this because that's what we're using in the diagram. Okay, and this is again the angle addition postulate. So once again, because this right here and this right here, they're the same thing, this and this are going to equal. So this is the transitive property. So the measure of angle DBA is going to equal the measure of angle EBC. And this is because of the transitive property of equality. Okay, and that is example number 1. Let's take a look at example number 2. Okay, example number 2. Name the property that the statement illustrates. Okay, so you have if angle T is congruent to angle V and angle V is congruent to angle R, then angle T is congruent to angle R. To me, that looks like, if you look on page number 56, okay, so that all those theorems are right there. So this is going to be the transitive property of angle congruence. It's not a theorem. I mean, it's not a postulate, it's a theorem. Okay, so it's a properties of angle congruence, but it's a transitive property. Okay, B. If JL is congruent to YC, then YC is congruent to JL. So if you're looking at page 56, okay, that's the same thing as the symmetric property. Of segment congruence. So 2 is easy because you're just identifying what the property is going to be. Okay? Okay, so let's look at the next example. Okay, now the next 2 examples are going to be proofs. Okay, so brace yourself. All right, now this next problem, it's not very lengthy. It says write a 2-column proof for the symmetric property of congruence. So symmetric property of congruence says that if LM is congruent to NP, then NP is congruent to LM. So just like at the beginning I showed you guys like an example of a proof, this is going to follow the same strategy. Okay, we are going to convert these congruent statements into statements of equality. We're going to apply the symmetric property of equality and then turn it back into congruence. Okay, it's going to make more sense once you see me do it. Now guys, with proofs, in order to learn how to do proofs, there is no 1, 2, 3, 4 step way of learning how to do proofs. You learn proofs by looking at plenty of proofs, picking up on the strategies, and becoming experienced with it. It's going to take you some time to learn proofs. So if proofs gets your anxiety up, I am so sorry, but it is what it is, guys. Okay, so first things first. Okay, you guys will do just fine. All my students have survived proofs. Okay, that is given. Okay, now, what do we know about 2 segments that are congruent? If 2 segments are congruent, then their measurements are equal. So that means that LM equals NP. And this is simply the definition of, now I'm abbreviating, congruent segments. In math, you want to learn how to abbreviate, otherwise you're going to be writing forever. Now, when you do this step, this is a real number. These are actual numbers, and you can apply any of the properties of real numbers. So that's what we're going to do. So I'm going to apply the symmetric property of equality, okay, by flipping those 2. So that's the symmetric property of equality. So now I know that these 2 segments have equal lengths, therefore by definition they're going to be congruent. So NP is going to be congruent to LM. And this is by the definition of congruent segments. So it works backwards. I use the same definition to convert a congruent segments into equality and vice versa. So it works both ways. Okay, so this is example number 3. Notice the main structure of this. The first piece of information is your given, and the last statement is what you're trying to prove. It's what happens in between that is the magic. Okay, and I know this magic might want to make some of you disappear. Sometimes it makes me disappear, but I've been doing this for a long time, guys. All right, so let's take a look at the last example, example number 4. Okay, so in example number 4, it says, prove this property of midpoints. If you know that M is the midpoint of AB, prove that AB is equal to 2 times AM, and that AM is half of AB. So we're going to prove this one first, and then after that, it's just going to be one more step to prove this one. Okay? So it's going to look complicated, but honestly, it's really not. Once you see the strategy and you walk through it step by step and pay attention to everything that we're doing, it's not going to be hard to understand. It's hard to come up with these in the first place. Okay, so this looks familiar. We have talked about midpoints before. I'm going to go through a bunch of lead this semester. Okay, so M is the midpoint, I abbreviate midpoint, of AB. Okay, that's given. Okay, so what does that mean? Okay, if M is a midpoint of AB, that means that this segment and this segment are congruent by definition. So that means that AM is congruent to MB. Definition of a midpoint. Abbreviate midpoint. Okay, so what's that going to do? Well, because those two segments are congruent, their lengths are equal. Okay, so AM equals MB. Okay, and this is because of the definition of congruent segments. All right, so now what we got to do is we need to involve the segment addition postulate. How are we going to do that? Well, you have two segments, put them together with one. So look, AM plus MB equals AB, right? AM plus MB equals AB. Yeah, it does. That's the segment addition postulate. So what is that going to help me? Okay, well, keep in mind what I'm trying to prove. I'm trying to prove that AB is 2 times AM. So I'm going to look at this right here, okay? And I'm going to look at this right here. If these two are the same thing, can I just replace this with AM? Okay, so I have AM plus, instead of MB, I'm going to write AM, and that's going to equal 2AB. So what did I do? I just literally did a substitution. Well, how is that going to help me? Well, hello, look, you got AM plus AM. Well, isn't that equal to 2AM? 2AM equals AB. And what did I do? I literally just simplified. Now look, I've already proven this piece right there. Okay? Now you can have like I've been saying that this needs to be your last statement. If you have two things to prove, you can split them up. Now on the last statement, I'm trying to show that AM is half of AB. So I can literally just divide both sides by 2 and get AM equal to AB divided by 2, which is the equivalent to half of AB. And what did I do? I did the division property of equality. Okay? So guys, I know this is a lot of steps. It's only 7 steps. It's not going to be the longest one we're going to do. We're going to do a lot more than that. Okay? So I'm going to ask for your patience for this chapter because you're going to need it. Okay? All right, so make sure you guys complete your extra practice on this section, and we'll see you later.